Students, now let us look at an interesting phenomena of just in time. We know, it is known to us that what is just in time. Here we will be using just in time models for our inventory. So you may know that when we say just in time for inventory, that means inventory would ideally be required when it is, would be ordered when it is required. So how can we actually incorporate it in EOQ type models? That's the case here. We will be discussing 3 models representing just-in-time ordering situations. The first model actually considers the blanket ordering. Blanket ordering means it would be like the whole order, in which an order is placed for a certain amount but is delivered by the vendor in small amounts at regular intervals. That means a blanket order would be placed, the whole order would be placed, but the vendor or your supplier would be supplying it in small amounts. When you require it, it would be coming to you. That is the actual essence of just in time. This model actually essentially determines the frequency of delivery given the blanket order quantity. Frequency of delivery. When you need that order. Can I determine it before time? That is the case here. The second model would actually determine the order quantity and the delivery frequency. So the first model is more about calculating the order frequency. Frequency क्या होनी चाहिए उस order delivery की जो small amount है. दूसरे, the second model actually is about determining the order quantity and the order frequency simultaneously. The third model actually determines the order quantity and delivery frequency considering multiple vendors. So order quantity plus the order frequency when there are multiple vendors with you. In this model, actually, the entire demand for the pre-specified period, that is 1 quarter, is placed in the blanket order. I'm starting with the first model, with the actual order delivered in several shipments on an installment basis. So there will be small shipments, frequent shipments when needed, but the blanket order would be placed at the start. The cost of transportation increases, yes. So for just in time, my cost of transportation would increase, especially this model would not be that attractive if your supplier is located at a very distinct place. Then in that case, the shipment cost would be much higher. As the number of delivery increases, however, the cost of carrying inventory decreases. Your carrying cost actually decreases. So there is a trade-off. The objective is actually to seek the trade-off between these two costs. आपने trade-off करना है. Your carrying cost would be going low, but at the same time, your transportation cost would be going high. It's most of the time it becomes contemporary. It depends upon the situation in which you are. So if the distance is not that long from your supplier, you can have just-in-time model. So there is a trade-off between the two costs in order to determine the optimum number of deliveries per year. Frequency क्या होनी चाहिए? पहले में ये, this is the case. Now let me introduce the notations which I will use for just-in-time models. A would be the ordering cost. So as usual, मैंने पहले भी उसको A ही लिया है. From the perspective of retailer, समझाना आसान है. C is the unit cost per purchase cost. D is the annual demand. L is the lead time. Q is the order quantity. N is the number of deliveries per order. Big N is the number of deliveries per order per year. So what is small n? Small n would be the deliveries per order. एक order में आप कितनी deliveries कर रहे हैं, that is small n. Whereas big N is the number of deliveries per year. These are the total number of deliveries for different orders. I is the interest rate per year. R is the reorder point. S is the safety. Small s is the safety stock. V is the transportation cost per delivery. Small t is the transit time in days. Big T is the unit transportation cost. S is the storage cost per unit. Small h is the holding cost per unit given by, we now know that it's I being the interest rate into C plus big T. Big T is the transportation cost, unit transportation cost. C total is the total annual cost, and now we can specify the model as follows. So my total cost would be the ordering cost plus purchase cost plus inventory carrying cost plus transportation cost and in transit cost. There is no difference. जो हमने EOQ में डिस्कस किया उसी तरह यहाँ पर मौजूद है, लेकिन the execution would be different. Now, the number of deliveries per year, जिसको आप setup कहते थे, that is ND over Q. Now, what would be the size of delivery? 8 दफा जब आप डिलीवर कर रहे हैं तो what would be the size? That would be D over big N. And what about your average inventory? Then average inventory here in just-in-time model would be D over 2N. Here you will divide it like 0 plus D divided by 2. Average demand आप बना देंगे उसे rather than average inventory बनाने के लिए. And you will multiply it with N. So that is the difference. The size of the delivery and the average inventory were not like that in the basic EOQ model. Just in time model, जो blanket model है, जो the first model है, उसमें the frequency of delivery would be different. That वो इस तरह calculate होगी. Now, जो बाकी cost आपके पास मौजूद है, उनको calculate कर लें. So average ordering cost would be equal to my cost per order multiplied by number of orders per year. That is similar, AD over Q. What is my annual purchase cost? That is CD, no difference. But what is my annual holding cost here? That would be the average inventory, जो generic formula है, that is the average inventory multiplied by the holding cost per unit. Now here it would be D small h over 2N, because my average inventory is no more Q over 2. It is now D over 2N. Now, what about my transportation cost? ये transportation cost भी change होगी. The transportation cost per unit multiplied by the annual demand plus transportation cost per delivery multiplied by number of deliveries. So transportation cost per delivery को हमने V से represent किया है, तो number of deliveries जो है पूरे साल की वो big N है. So my whole expression would become T into D plus VN. Now, the in transit inventory cost, that would remain the same जो हमने पहले EOQ के अंदर जब इसको incorporate किया था. It would remain like that. That is ICDT over 365. Just in time में it's the same. Now, what would be my total cost for given N? Now, here is the difference. In a blanket model, it's not Q. It is actually dependent upon the frequency of ordering. How many deliveries are there? How many deliveries? N, big N, per year कितनी deliveries करनी है? So, this is your ordering cost plus your purchase cost plus your holding cost, which is different here, plus your transportation cost plus. So, these two expressions are actually different. So, what we need to do? Same, we need to take the first derivative of this cost function with respect to N, big N. Then we need to take the second derivative, and if it is greater than 0, we would say the function is minimized, and then we have to compute the first derivative equal to 0 and solve it for N. जब solve किया N के लिए, तो we have this expression N optimal star से represent कर दिया would be equal to DH divided by 2V under root. So under root of DH over 2V would be my N optimal. Right? The focus here is actually on determining the number of deliveries per year rather than looking at the optimal quantity. So this was the first model of just in time. In the next models, we would be looking at the optimal quantity as well as the optimal quantity Q as well as the number N optimal numbers. Thank you.